All right, you guys, so far we have converted rectangular coordinates to polar coordinates, and we've also converted polar coordinates to rectangular coordinates. Now we're going to convert entire equations. So equations such as r equals 3 sine theta, r equals 2 plus cosine theta, or r equals theta are examples of polar equations where r and theta are the variables. So the simplest equation for many types of curves turns out to be a polar equation, and we're going to evaluate r in terms of theta until a pattern occurs. Okay, so what that means, so far we've been in the rectangular system. So anytime we've gone to graph anything before, like in college algebra or intermediate, our equations usually were in the form y equals something, something, something. Now, since we're in polar, our equations are going to look something like this: r equals something, something, something in terms of theta. Okay, so that's going to be our goal, to convert our equations from rectangular to polar and then polar back to rectangular. So now in this section, when we are using our graphing calculators, we've only switched back and forth between two modes, radians and degrees. Now we are also going to be entering into polar mode, okay? So I will do another video where I show you guys how to do that on your calculator, okay? Now we're going to focus on converting those equations back and forth. All right, so let's take a look at these examples. So it says for each rectangular equation, give its equivalent polar equation and then sketch its graph, okay? So the one thing that I like to do is, especially if I know what shape this is supposed to be in the rectangular system, because they should make the equivalent shape in the polar system, I always sketch my shape first, okay? So for A, we have y equals x minus 3, okay? In the rectangular system, this is a linear equation, okay? And because it's linear, the shape that it makes is a line, okay? The easiest way to graph a line is if your equation is in slope-intercept form. It is. So for this line, the slope is 1 and the y-intercept is -3. So that means I would rise 1, run 1, rise 1, run 1. So my equation in the linear system would look something like that. So I know that when I convert this equation to polar and I graph it using my calculator, I should get the exact same shape, okay? All right, so let's take this equation. So we have y equals x minus 3, and we're going to convert it to polar. Now, when we're converting it to a polar equation, remember we have those conversion factors. X is equal to r cosine theta. We have y equals to r sine theta. And we have that r squared equals x squared plus y squared. So those come in really handy when we're trying to convert these, okay? All right, so if we have a y in the polar system, y is equivalent to r sine theta. So I can replace y with r sine theta. And in the polar system, x is equivalent to r cosine theta, okay? Now, my goal is that when I'm done, I have an equation that looks like r equals something, 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 which means that r needs to be isolated on one side of the equation by itself. So all of my terms that have an r, I'm going to move them to the left side. So that means this r cosine theta, I'm going to subtract from both sides. So that's going to give me r sine theta minus r cosine theta equals -3. And I need r by itself. So since both of those terms have an r, I can factor the r out. It's the GCF, or the greatest common factor. When I do that, it leaves sine theta minus cosine theta. Okay? And if I want to get r by itself, I can divide both sides by sine theta minus cosine theta. So that gives me r equals -3 over sine theta minus cosine theta. All right. Now, if you put that in your calculator, this equation, you're going to see that you get a line as well. Okay. Cool. All right, let's look at the second one. B. All right, so for B, our equation is x squared plus y squared equals 4. Okay, so if you guys recognize that equation, that is actually the equation of a circle. Okay, and in order to graph a circle, you need two things. You need to know the center, and you need to know the radius. The center of this circle is at 0, 0, and the radius is the square root of 4, which is 2. So if I were to graph this circle, the center would be at the origin, and I would go 2 out in each direction and connect. So there's my circle. So I know that when I convert this to a polar equation, I better get a circle back because they need to give me the same shape. So I have x squared plus y squared equals 4. Okay. Now I'm going to use my conversion factors. Well, I have a conversion factor that says x squared plus y squared equals r squared. So I can replace this whole quantity with r squared equals 4. Okay, and then I can square root both sides. So r equals plus or minus 2. That is the equivalent polar equation. Okay, and if you place this into the calculator, you will get a circle as well. Okay.